And as I've mentioned, with pure functions, the correct solution to handling possible or potential errors is that we use Scala's error handling data types. And this means that we return one of these three built-in types, so either option, try, or either. And so down in this section here, what I do is instead of taking in a string, I'm taking in a file. But here I define word count to take in a file. And then because reading a file can potentially fail, you could get a file not found error. You might get a permission error where you can't read the file. You want to return one of these error types here. So this is the beginning of a signature for option. This is the beginning of a signature for try. And then the same thing here for either. And again, the whole key of this is that you're accounting for the possibility that an error may occur inside your function. Next, some people don't like the term wrapper, but I use this at least at the beginning to explain what error handling types are. And to me, basically, they're a wrapper that contains one of two possibilities. So the first possibility is that your function succeeded, and then you can access the success value. And then the other possibility is the function fails. And then with that, you can access the error value. So with each of these types up here, there's an option or ability to handle both the success and error values. And you'll see what I mean by that in just a moment. But right now, if you think of these as being containers, as I mentioned, you're either getting a success value or a failure value. You're not getting both. You're getting one or the other. Now, a great thing about this approach is that unlike exceptions that short-circuit your code, with these, you're just returning another data type from a function. So you treat the result as value, and then you continue writing your code as algebra. And again, you'll see what this means shortly. But notice that up here in these examples, I'm returning a data type, or this data type, or this one. Down here, I note that the three error handling types take slightly different approaches. But the essence of them is still the same. We return a success value or a failure value. And now let's take a little bit of a look at these three. So the way this works is, if you want to think about OOP for a minute, each of these types have the parent types, and that's usually what we talk about is the parent type is option, or the parent type is try, or either. And then the parent types have two subtypes. So the way it works is that option has the subtypes sum and none, try has the subtypes success and failure, and then either has these subtypes right and left. So these images show what the class hierarchies look like. And if your background happens to be in Java or some other language that uses interfaces, you can think of option, try, and either as being interfaces, and then their subtypes are implementations of their interfaces. So what I mean by that is you can think of either as being an interface, and then left and right as being two implementations of that interface. And these guys you can think of as being types. So you can think of left as being a type that contains a value, and then right as being a different type, slightly different type, that also can contain a value. So that was a quick little overview of functional error handling and these three data types and the type hierarchy. And now we're going to look at how these work with some code, and then how we can apply these to our new word count function. And as a brief look at some real-world code, here I talk about option and how you can think of it as being a parent type or maybe an interface, and then sum and none are concrete instances of that. And then over here I have this makeInt function that I use in many of my examples. And the way this works here is makeInt takes a string as an input parameter, and then I declare that it returns an option. And specifically, it's an option that will contain an int in the success case. So what I mean by that is inside the body of the code, what I do is I call toInt on that string that I'm given as an input parameter. And because that can throw an exception, what I do here is say, okay, in the success case here, when this doesn't fail, like if it's given the number 0 inside of double quotes, that's going to return the integer 0 inside of this sum data type. So again, sum is a child of this type, so that's why you can declare the function this way. So in the success case, it returns a sum, but then when this code right here throws an exception, the control flow comes down here to the catch area of the try-catch block, and then we catch the number format exception, and then the function returns a none instead. So this is like if the string was something like hi mom, then that would fail to convert to an int. It would throw the exception, it would be caught, come down here, and return this none instead. And that's a little look at how we get rid of exceptions by capturing them here inside of our functions, and then we declare to the outside world, hey, this is something that can fail here, so I'm going to give you an option. If it succeeds, the value, the integer value, will be inside the option as a sum type, and if it fails, you're going to get a none. And then the callover function just handles this option type right here in an algebraic sense. So I show it here. One way to do that is you call make int on a string, and then you start a match expression, and then you match on the two possibilities. So one possibility is you get a sum with an integer inside of it. So then here I say the conversion worked, and then I show that right there. And the other possibility, the only other possibility, is you get a none, and then I print that the conversion failed. So this is a little bit of a hint at how you handle options using match expressions in Scala.